And welcome to Startup Hack. Today we are going to discuss about seal keyword in .NET C#. So let's jump right in. In this video, we are going to discuss one example of the ways by which we can help the compiler optimize our code. This way is using the seal keyword. Make sure to check out the link down below because we always provide a code sample that you can pull down and follow along so you can see in our project. If you are a .NET developer, even a beginner, you should know by now that there is a keyword in the .NET framework called seal. This keyword could be used in class definition, and then it means that the class could not be inherited by any other of classes. It looks like this. Or even in a method declaration, and then it means that the method could not be overridden anymore by any other method in a child class. In other words, it breaks the method override series at the level where it is used. It looks like this. Therefore, what we can understand from this is that we use the seal keyword, we are actually promising the compiler that we don't have any intentions to inherit from a class or override a method. Having said that, let's now see if that would mean anything to the compiler.
Do you want to earn $100,000 a year? Do you want to become a software developer within just 3 months? With our amazing course and awesome tutors, you never have to worry about getting stuck. We help students to learn skills that companies want to hire. We are Startup Hack. Don't forget to subscribe our channel. So let's get started.
Alright, let's start with the first topic, base code. Let's start with some base code to be used throughout the explanation. This is the base class that we would use as a top parent. In this class, we have the following members defined: public virtual void do something method, public void do something else method. Now there's another class, my class. This is the class that would inherit from base class but without using the seal keyword in the definition. In this class, we are overriding do something method which is inherited from the parent base class. After that, my seal class. This is the class that would inherit from base class, but this time we are using the seal keyword in the definition. In this class, we are overriding do something method which is inherited from the parent base class. Now let's proceed and see if there would be any difference from the compiler's point of view between using my class and my seed classes. Okay, now calling virtual method. To validate if there would be any difference from the compiler's point of view between calling a virtual method on both my class and my seal classes, here's example. The performance of calling the virtual method on the seal class is much better than calling it on the non-seal class. But why? Let me tell you. On non-seal class, while calling the virtual method on the object created from my class, at that moment the compiler doesn't know if there is some code that reinitializes my object with a new instance of a child class of my class or not. This assumption is valid because my class is not sealed, and this means that it could be inherited. Based on that assumption, the compiler could not decide at compile time if the actual implementation of the do something method would be the one provided by my class or any other child class of it. Thus, the compiler would write some instructions to be executed at runtime to check that at the moment of executing the do something method, which implementation would be the right one. This for sure would cost more processing and time. On seal class, while calling the virtual method on the object created from my seal class, at that moment the compiler doesn't know if there is some code that reinitializes the underscore my seal object with the new instance or not. However, the compiler is sure that even if this happened, the instance would still be of my seal class as it's its seal, and this means that it would never have any child classes. Based on that, the compiler would decide at compile time the actual implementation of the do something method. This for sure much faster than waiting for the runtime. Okay, now calling non-virtual method. To validate if there would be any difference from the compiler's point of view between calling a non-virtual method on both my class and my seal classes. So here's example. The performance of calling the non-virtual method on the seal class is better than calling it on non-seal class. Alright, the next topic is type checking. To validate if there would be any difference from the compiler's point of view between checking the type of an object using the is operator on both my class and my seal class. So here's the example. The performance of checking the object type on the seal class is better than calling it on the non-seal class. But why? Let me tell you why. On non-seal class, while checking if the type of the object is my class, the compiler needs to check if the object is of the type my class or any of its child class. Thus, this leads to more instructions and for sure more processing and time. On seal class, while checking if the type of the object is my seal class, the compiler needs to check if the object is only the type of my seal class, nothing else. This is because my seal class is sealed, and this means that it would never have any child classes. Thus, this leads to fewer instruction and for sure less processing and time.
Alright, let's move towards the next topic, typecasting. To validate if there would be any difference from the compiler's point of view between casting an object using the as operator on both my class and my seal classes. So here's example. The performance of casting the object on the seal class is better than calling it on the non-seal class. But why? Let me tell you. On non-seal class, while casting the object as my class, the compiler needs to check if the object is of the type of my class or any of its child classes. Thus, this leads to more instructions and for sure more processing and time. On seal class, while casting the object as my seal class, the compiler needs to check if the object is only the type of my seal class, nothing else. This is because my seal class is sealed, and this means that it would never have any child classes. Thus, this leads to fewer instructions and for sure less processing and time. Okay, now storing object in array. To validate if there would be any difference from the compiler's point of view between storing an object in array on both my class and my seal classes. So here's the example. The performance of storing an object in an array on the seal class is better than calling it on the non-seal class. But why? Before going to details, let me first remind you of an important point. Arrays are covariant. This means that if we have following classes defined, then the following code would be valid. Additionally, we can set an item inside array of A to an instance of B as follows. On non-seal class, while setting an item inside the my class objects array, the compiler needs to check if the instance my class object we are using is of type my class or any of its child classes. Thus leads to more instructions and for sure more processing and time. On seal class, while setting an item inside the my seal class objects array, the compiler needs to check if the instance my seal class object we are using is only of the type my seal class, nothing else. This is because my seal class is sealed, and this means that it would never have any child classes. Thus, this leads to fewer instructions and for sure less processing and time. Alright, the last topic is early failure detection. In addition to the performance gain we can get by using the seal keyword, we can also avoid some runtime failures. Let me show you an example. If we write the following code, the compiler at design time would not show any warnings or error because actually obj could be of the type my class or any of its child classes. Therefore, the compiler needs to wait for the runtime to do the final check. For sure, if a runtime the real type of obj returns out to not implement my interface, this would cause a runtime exception. However, if we write the following code,
The compiler would show an error CS0039 in the design time because obj could only be type of mySeal class, nothing else. Therefore, the compiler can instantly check if mySeal class implements IMA interface or not. Thus, this means that using the seal keyword enabled the compiler to perform the proper static changes at design time. I would always recommend using the seal keyword whenever applicable. This is not only for the performance gain you might get, but also because it is a best practice from the design point of view, to the extent that Microsoft was actually thinking about making all classes sealed by default. Finally, I hope you enjoyed this video. Don't forget to subscribe our channel and hit the bell icon for latest update. To joining our course, you can simply go to our website called startuphack.com. Thank you.